Let's study unit impulse function and unit step function, both for continuous and discrete time signals. Okay, unit impulse and unit step function. Unit impulse, let's start with discrete system. It is denoted like this: del of n. Its value is 0 when n is not equal to 0, and its value is 1 when n is equal to 0. It is a unit impulse, so it is like this. At 0, its value is 1. Elsewhere, minus 1, minus 2, minus 3, 1, 2, 3 and all, it is 0. This is your impulse function. Okay, you have studied about these functions in your 12th class also. Second is unit step function. This is unit impulse function, and second one is unit step function. This unit step function, its value is 1 when n is greater than or equal to 0, and its value is 0 when n is less than 0. That is, it is 1 for greater than 0. So after this you will have 1, but below this it's 0. Okay, now what about shifting? If we have un minus 2, it means after 2, that is at I told you n greater than 0, it is 1 n greater than or equal to 0. So in place of n, what I'll do put n minus 2. This means this value. I have solved some questions which is related to this type, so you understand this. So here what you will have, this function, this graph, that is 2 onwards it is 1. This is n minus 2. If it is n plus 2, this means n plus 2 greater than or equal to 0, that is n is greater than minus 2. This is 1 for n greater than or equal to minus 2. So from minus 2 onwards, minus 2, you have 1, 1, 1, 1. Clear? Similarly, you have del n, impulse. So I think this is clear to you. Now, we'll understand a few more things. Del n, it can be represented like this: un minus un minus 1. How? See, I am plotting it here only. Okay, let me plot it this side. First is un. Un will be like this at 0, 1, 2, 3, 4 and so on. 1, 1, 1, 1, 1. This is un. And what will be un minus 1? I told you this will be from 1, 2, 3, 4 and so on. 0 and less, it will be 0. So this minus this, if you subtract this from this, these signals will be, here it will be 1 minus 0. Otherwise, this minus this 0, this minus this 0. So ultimately what you will get? You will get a value of 1 at 0. Otherwise, 1, 2, 3, minus 1, minus 2, it's 0. So del n can be represented like this. From here, we have a very important result, that un is equal to summation n, or let's say m, equal to minus infinity up to n of a what? Of an impulse function. Because minus infinity to n minus 1, it will be 0, and it will be 1 at this only. Clear? So this is a very important figure that you must understand. And if you put this m equal to n minus k, or k equal to n minus m, you'll see this limit will be k equal to, this is minus, so this will be infinity, and when this will be infinity, here you will have 0. See, so minus infinity is infinity, and when n minus, here what you have, n minus m, here it was n, so when you put the value n, it will be 0. So infinity to 0, and here what you will have, in place of m, n minus k, that is shifted impulses. In case of shifted impulses, you can write like this, or it can be turned around also, that is k equal to 0 to infinity del n minus k. This is also very logical, that from 0 to infinity, 0, 1, 2, this you will have impulses. Okay, so you will get un. So we have these three very important expressions you should always keep in mind. This to n del of m. This was the relation. So this is equal to this is equal to this, and this can be expressed like this. These are very important relations. You should commit these expressions to your memory. Okay. Now, this is also called sample. Why sample? Because if you sample it with any signal, you have a signal xn and you multiply it with del n. What will be the value? You will have value of this function only at this 0. So whatever be x can have many values. So whatever be the value of x at 0, only that you will get. Okay. So it is also called sampling signal. And more generally speaking, we can write as n minus n0. That is, if it is shifted to n0, we can say this will be the value of x at n0 into del n minus n0. Okay. So you should understand this, keep this in mind. Now, very similar to this is your continuous time signal. There are differences undoubtedly, but the concept is almost same. You have del t. What is del t? It is, if this is t, at 0 you will have impulse. That is del t. And you know that is, you have value 1 for unit impulse. It is 1 for t equal to 0, and it is 0 when t is not equal to 0. So this is the definition for continuous signal. And ut, it is 1 for t greater than equal to 0, and it is 0 for t less than 0. That is, it is like this. Okay, you know ut function. As you saw there, minus infinity to n. Similarly, your ut can be expressed as minus infinity to t del of, say, tau d tau. This is a very important expression. You should keep it in your mind. You'll need it while solving your signals problems. Even in convolution theorem and all, you'll need this. So you should learn this. And from here, you can say that del t is actually equal to dut, this function, by dt. That is time rate of change of this unit step function is this. Another important expression, as we saw in discrete time, is 0 to infinity del when we have a shifted signal. So let's say the signal is t minus this sigma. So this will be d sigma. This is another very important expression or relation that you should keep in mind. Okay. Now next, as we saw how it samples in the discrete time domain, similarly, if we have xt and you multiply it with del t, what you will have? You have whatever is a value at this into del t. This is sampling here also. Similarly, if you have xt into del t minus t0, it is your x at t0 into del t minus t0. Okay. These expressions are very simple and very logical, and you should keep them in mind. Now, based on the discussion or based on the concept of impulse, unit impulse and unit step, we can have so many questions, and we have seen such questions while we were solving so many examples in our first, second and third video. So you can correlate it. Here we'll see a very important question, a very important concept. This will clear your concept. It says if xt is del t plus 2 minus del t minus 2, calculate the value of E infinity for the signal, this signal. This is a signal which is dependent on this, and then we have to, first of all, we will have to understand what is this signal when it is put into this integration, and then we have to find E infinity. You know what is E infinity? We have seen E infinity and P infinity. It is minus infinity to infinity mod of xt square dt. You remember this? And for P infinity it was limit t tending to 0. It was 1 by 2t minus t to t. Okay, square. This was our case. This is the expression for E infinity and P infinity. Just give you a recap. We have to find E infinity. So here we have yt. So we have to find this yt square. So what is yt? First of all, we'll have to see yt is equal to minus infinity to t x tau d tau, but xt is given that form. So x tau is basically del tau plus 2 minus del tau minus 2 d del tau. Now, if you remember, we just saw that ut can be expressed like this: minus infinity to t del of let's say tau d tau. This is the expression. Now, this is very similar expression. So you can, from this expression, if you compare this, what you will see? You will see this is u t plus 2 and this is u t minus 2. This expression and this expression. So we can express it like this. It is basically u t plus 2 minus u t minus 2. What is this function? Ut plus 2 minus ut minus 2. Ut plus 2, see, I am drawing a figure. T plus 2 means from minus 2. So from minus 2, it is this function. This is ut plus 2 minus, I am rubbing this now, minus another function that is ut minus 2. So if this is 2, it is like this. So if you subtract this function ut plus 2 minus ut minus 2, what you will get? You will get a function like this: from minus 2 to plus 2, you have this value ut. This side is truncated. So this is the final signal that we get. Okay. So to this, any signal, the value of the signal where t is less than minus 2 is 0 and t greater than 2 is 0. So you have value between minus 2 and 2 only. Clear? You have to understand this. Ut plus 2 minus ut minus 2 means minus 2 to this. Now this is clear. So we'll, and this is what? It is a unit step function. So we have to find E infinity. What it is? It is minus infinity to infinity, whatever be the signal, square dt. Now the signal is a unit step function, so this will be 1. So 1 dt, and the limits are minus 2 to plus 2. This is the limit, minus 2 to plus 2, otherwise it is 0. So this is t minus 2, 2. 2 minus minus 2, so this is 4. So we get the value of E infinity, that is equal to 4. Clear?